So we talked about designers specifying the installation of a flow meter, just so you know accurately, even though you're going to design this irrigation system, do the calculations, maybe understand what type of emitters or spray heads or whatever you might be using. It's important to have an accurate measurement of how much water you're using per your station or your total irrigation system. And then also it's critical to just mention about winterizing your systems. Of course, I think getting all the water out, because there's a large potential for freezing up on a roof, those pipes freezing and cracking, but then also being sure that you don't, it might be okay to leave an irrigation system on accidentally and having a pipe crack at your home, depending on if it's near your basement or something like that. But on a rooftop, it's very significant because you might get a lot of erosion, and we had a break up here on this roof where a pipe hose clamp actually came undone, and I don't know, 10,000 gallons of water, 30,000 of course, 30,000 gallons of water flowed out before it was caught during a weekend. Of course, it was a Friday afternoon or something like that. It may have happened, and then it flowed, who knows, all weekend.
If that happens, part of this is economics. We charge a sewer fee for water use in buildings, and the sewer fee is 3 times more than the cost of water itself. So if you don't have a special meter, then you're not keeping track of how much you're spending, and if you have a break, then the Water Bureau will deduct the cost associated with problems like that sometimes. And if you have one of these and it's on a large project, a larger building, then you can have use that meter as a deduct meter, and then the sewer fee will be deducted. So that can add up to, on a large building, it can add up to hundreds, if not over $1,000 worth of savings in the course of an irrigation season.
Mm-hmm. Yep.
I was just going to say, regarding the break in your line and the 30,000 gallons, one thing you may want to include for those larger systems is a flow sensor and a shutoff valve, so that it shuts the system down when you have a break and you don't need to be up there to actually see the water flowing.
Yeah, I haven't gotten to that yet.
Okay.
And so what we have here is this is a good photograph of our system that we have upstairs on the 15th floor. So water supply comes in, you've got your typical backflow preventer. Here, water comes down, and then here's where this flow meter has been installed. And then subsequently that data logger, which is that's it. That's just a close-up of it. So that's continuously reading the flow through the meter. And then, so yeah, that's our setup here, and I think it'd be a great idea to use. And then the point that was being made is that in your controllers, you can have a master valve. There's often a little master valve place to put in where you can have a shutoff. So if you can set it up where if it flows, if there's a flow over a certain amount of gallons or a flow rate, that controller will read that flow coming through your flow meter here and shut off that master valve automatically. And then some of the sophisticated ones will send you an email or call you on your cell phone, or I don't know, something like that. Put a letter in the mail and let you know that the system, there's been a break, and please come and check it. And so I think that would be, especially on rooftops, a very good idea to consider getting a controller that may have that option, just to reduce that 30,000 gallon flow that you might get. Yeah.
Is there any kind of moisture sensor that you could just put at places in the soil so the system only comes on when the roof on the soil gets to a certain level of dryness?
Yeah, definitely. There's the sophistication on controllers is getting very high, and of course that increased with cost. But I have like a little rain gauge on mine, so I hung it off my roof, and so if it does rain a certain amount, it'll just click it off, and so I won't be that guy as you're riding by on your bike and it's raining and his irrigation system is on and people are cursing it. That's but then they get much more sophisticated than that, definitely with moisture sensors and multiple sensors in different areas and rain gauges and all those things. And some of them you can hook up to actual, like our hydro network. They'll actually have rain gauges and weather stations with wind, and so if it's blowing too hard, they won't turn on the irrigation system, all those things. So, but they also precipitously increase in cost as well.
One thing about the larger projects like this, we have numerous microclimates on the roof. So a moisture sensor in one location may trigger it to go on, and then does the whole thing go on? And we actually, I don't know if you were there when we were having the contractor go through the clock with us, and we have these sensors, and it's drizzling rain as we're looking at it. And I asked him, okay, what's it set to do today? And he said, well, it's set to come on. So I have heard of those being installed on a number of Ecoroofs, and it's back to that question: is this technology really been tested on an Ecoroof environment versus in the ground environment? So just kind of keep an eye on that kind of thing.
Right, that's a good point. Yeah.
I was just going to say that both Hunter and Rainbird have sensors. Rainbird uses that one that's not necessarily going to have anything to do with your microclimate, but it's Portland in general. Hunter's coming out with one that is site-specific this January, and it's very, very affordable, even for a residential project. And you just hook that up to your controller, and it monitors wind, rain, evaporation.
The very low-tech way of doing it is the way I garden on my deck, which is every season I let it dry out and find the plant that wilts first, and then I just keep an eye on that plant.
Personal observation, I think, is always the best.
Yeah, that's fact. Definitely. We're going to keep going here. So just wanted to run through just the other pieces that you're going to need for your irrigation system. So we talked about flow meters, valves, controllers, backflow preventers. Irrigation pipe is just one that's out there, of course, that you're going to need. On the left is PVC pipe, hard PVC pipe, and on the right is HDPE, flexible pipe. You can solvent weld the PVC, of course, to T's or couplers or whatever you need, or glue, I should say, those pieces. And then on the right, the HDPE oftentimes is used. Hose clamps are used to prevent that pipe from slipping off of the barbed end of a T right here. But again, we'll see in more slides that a lot of these pipes do heave or come out of the ground because of just the expansion of them. And then these, with a 4-inch soil, these hose clamps can often be subject to the environment and rust and potential failure if they aren't put on tight enough or what have you. And so this is where one of these did come off and leaked. So you can see there's the pipe coming out of the ground. We talked about this in the last one, where you might, as it's installed, maybe it was a cold day, you get it installed nicely, and then you come up there in the summer and this thing's popping out of the ground fairly high. And then here's your connection of a drip tubing, inline drip emitter that you might connect up right there at that T. And then irrigation valves. This is where your main line would come in right here, and then distribute water through to these valves and then onto your zones. But as you can see, we're talking about components that might be more compatible with Ecoroof systems. Right now, we're using what we have, and this looks a little clunky, and is something that we, it'd be nice to find something that's maybe fits a little bit better with an Ecoroof. I don't know what those designs might be, but we're using conventional systems right now.
So a valve box that's only 4 inches deep instead of 12 inches deep.
Right. And maybe the tops of these would be turned on their sides, so it would be a side valve or something like that could be a little bit more of a low-profile system. What's interesting is that for some reason around these irrigation boxes, the plant material has been munched, and we don't know whether it's a path of least resistance for us looking around the corner. This is up on our roof, or it's that we're walking around looking in the valve box, checking on things. So maybe it might be, when you're considering your design, maybe this area would be something that you look at for lots of foot traffic that you may get during your design, or include those maybe in a mechanical room if you have one. So the types of irrigation that you can do: manual watering. It's pretty simple. And as I realized, I had to use my ladder here because as I realized when I was watering it, just by standing there, that of course it would drip and run down the inside of my sleeve. And I ended up, the whole half of me was just absolutely soaked. So got the ladder out and did that. It was fairly simple, but did that just a couple of times this year for establishment. And then we have impact sprinklers. This might be a fairly simple way to do it. This is PVC pipe above ground with a little support bracket or piece of 2x4, it looks like right there, kind of low tech, and that will support those impacts from falling over when they're on. So this is, what you'd consider a temporary system, and it's surprising how efficient the impact sprinklers are in their water distribution. They're actually one of the most efficient when it comes to just how much water is placed from the irrigation head all the way out to the farthest point of that water spray. It does a good job of uniform distribution. And then overhead sprays, of course. This is a Portland building, again, installation. And what we have similar to the impact sprinklers, these overhead sprays needed a footing or a base so they wouldn't fall over. And what was used here was just looks like a pot, maybe a 10-inch plant pot. And concrete was put in there, and then it was piped through the bottom of that and into the zone. So these have kind of just a nice concrete little stable footing that they were installed throughout the rooftop. And they seem to be, it's not a bad technique. It seems to be doing pretty well and fairly stable.
One thing about that particular issue is that it seems in this industry, we need lots of things like that people make and that you can easily specify or buy,
right,
instead of customizing it for each one. So there's the opportunity for lots of products to evolve out of the Ecoroof industry.
And this is the kind of thing that, as a contractor, this is going to drive you nuts, because you're going to get this design and have this system and get up there and ready to install it, and you go, has anybody thought about how this thing's is it going to fall over? I don't know. So can you just make those? Can you just go ahead and mix the concrete and put that whole thing together? And that's a lot of hours, because there's a lot of irrigation heads up here. So yeah, Tom's right on having products that might be able to be utilized.
On this one, water just comes up the pipe and drifts where it needs to?
This is the, it doesn't have a spray head on it. So
It just goes vertically in the air and just distributes.
And then just goes to the spray head that's going to shoot.
Slide that shows it for you.
Yeah. So you'd put, so there's the spray, so there's a little concrete base pipe, and then the spray head. Yeah. And then there's the nozzles that you'd put on the top of that pipe. And then here's another one, just on overhead spray, that was pretty interesting, is using larger rotors, so you wouldn't need so many pipes and so many irrigation heads. But in order to reduce the UV exposure of this head, they put a stainless steel pipe around that rotor, and so it just pops up above that stainless steel pipe and then irrigates and then comes back down and is protected from sun and wind and all that stuff. So it's kind of neat, because they're meant to be buried, right? Conventional systems, you'd bury that thing in the soil, and only the top of it would be exposed to any UV. But yet, if you installed this, you might have a failure of this thing earlier than expected. A very one that's used often, I'd say, is inline drip emitters. So you'd bury these drip tubing in the soil. So maybe you'd put down a layer of soil, then install this drip tubing, and then put down another maybe inch or two above it, and they would be buried in the soil. There's, emitters that are spaced at 12 to 18 to 24 inches on center along this entire length. So water comes down this header, then fills up these lines, and then just a low little drip then would wet these areas. Here you can see again they're subject to kind of the heaving or the UV exposure and walking themselves out. So that needs to be taken into consideration. And then another thing is that these again are used for conventional soils that we might have that might have higher fine content, and we're using well-drained soils, and so this product may or may not be good for that, because a lot of those areas that would be wetted, that circumference of soil that would be wetted with that emitter in a conventional soil, may be smaller because of that well-drained soil on that Ecoroof. So you might not get that spread of irrigations. And I think the next slide shows you a good example of that. So here you can see where the inline emitters are, and you can see where they are not. And again, it's well-drained soils that is not allowing that water to move horizontally to these brown areas here. This is grass, not sedum, but it gives you a good example of what could happen. So maybe you space them closer together, or maybe you use emitters. You can use, instead of using 18 to 24 inches on center, maybe use ones that are 12 inches on center, those kinds of things.